Hello and welcome to this video on solving equations containing rational expressions. And this is going to be part one. I will put out another video after this where I'm doing the same thing, solving more equations that contain fractions. And in these fractions you're going to see variables, and it's just like solving any other equation. When I'm asked to solve an equation, I'm trying to figure out what number or numbers, there may be more than one, or none, but what number can I replace the variables with and make a true statement, like 5 equals 5, or 0 equals 0, 10 equals 10, something like that. Alright, so let's, I've got several examples for you here. Let's begin. So my first rational equation, right, we're asked to solve the rational equation, an equation with fractions in it. Alright, so I've got 5 halves, 5 over 2, plus 1 over z, or 1/0, 1 over z, equals 4. And if you want to write this as 4 over 1, that's fine too. Alright, if you want to make them all fractions. Alright, so I've got some steps in the procedure here, how we're going to solve equations with rational expressions in them. Alright, so I'm trying to figure out what can z be so that this is a true statement, that this side indeed equals this number 4 over here. Alright, so first I'm going to find the LCD, right, the least common denominator of all the fractions. That's, or the least common multiple of all the denominators. And then one thing I'm going to point out too is note that the LCD, right, it's going to be a denominator, right? I'm trying to find the least common multiple of all the denominators. We're going to start pointing out when is that equal to 0, right? The LCD can't be 0. So I'll make sure I'm going to figure out what values of the variable in this problem make this LCD equal 0 and know that the variable cannot be those numbers. Alright, so let's do that here. So the denominators are 2, right? And 2, when you factor it completely, is just 2. Z, right? And z, when you factor it completely, is just z. And again, technically this is over 1, 4 divided by 1, so you could say denominator of 1, but that's not useful information. Alright, so the LCD, remember, is made up of, you go through the factorizations of the denominators, and every factor that shows up at least once in a factorization of the denominators you're looking at is part of the LCD. So I'm seeing a 2, so this will have 2 to some power, and then times I'm seeing a z times z to some power, and the exponent on these is the largest number of times the factor appears in any of the factorizations of the denominator. So 2 appears once here, 0 times here. The largest between 1 and 0 is 1, so it'll be 2 of the first, or just 2. And the same thing for z. Z appears once here, no times there, so the largest between 1 and 0 is again 1. So the LCD is 2z. Right. And I'm going to make a little note off to the side that's going to stick with me for the whole problem. This cannot be 0. Denominators cannot be 0, so definitely this, this being my least common multiple of the denominators. What I would change all the denominators into if I wanted a common denominator, I don't want this to be 0, right? I don't want the LCD to have a value of 0. So what would make that happen? Well, there's a factor of 2. That's never going to be 0. That's just always 2. But this factor of z is a problem, right? If that were 0, that would be an issue. So I'm going to mark off to the side here, and this is going to hold true for the rest of the problem. Whatever value z takes, whatever value z is, it cannot be 0. And you can even see that in the beginning. Right? If z were 0, I'd have 1 divided by 0. 0 cannot be in any denominator ever throughout the entire problem. You You can't divide by 0. Division by 0 is undefined, means nothing. Okay, so this is important. Right? Keep this in mind. The LCD can't be 0. Denominators, period, LCD or not, cannot be 0. Great. So the value of z I get cannot be 0. We'll keep that in mind. Alright, so the LCD is 2 times z, as long as z is not 0. So as long as z is not 0, this isn't 0. Great. And then I can do the next part. Alright, step 2. Once you have found the least common denominator, I'm going to multiply both sides by the LCD, knowing that it can't be 0, right? Knowing the values that make it non-zero. Because you can't multiply both sides of an equation by 0, because then you'd have 0 equals 0, which doesn't give you any information. So that's why I'm pointing out the fact that this LCD can't be 0, because of this step. We're going to be multiplying both sides by it, so it better not be 0. All right. So I'm going to multiply both sides of the equation by the LCD. All right, and it's just, you've probably heard this before with equations, right? You got to keep balance. What you do to one side of an equation, you must do to the other side, to keep things balanced, to keep expressions equivalent. All right, so here's I'll write the equation again. You have 5 halves plus 1 over z equals 4. And then when I say we're multiplying the sides by LCD, that's what we're doing. Now this side has multiple terms, and you've seen in other videos of mine if you've been watching, when an expression has multiple terms and I'm doing multiplication, put it in parentheses. Right? I'm multiplying not just the first term, but the entire thing by the LCD, so by this 2z. So there's going to be some distributing here. Alright, so 2z times both these terms. And then same thing over here, I'm multiplying. Now it's only got one term, I'll put it in parentheses, you don't need to. But then times the 2z over here as well. Alright, both sides are multiplied by the same thing. And again, we're marking off the fact that z is not 0, so that way I'm not multiplying both sides by 0. Wonderful. Now, the whole reason for this multiplication by the LCD is to get rid of the denominators. Right? You're going to see in a second here that all the denominators, right, since they're basically the denominators go into the LCD evenly, so you'll be able to divide out some common factors. So look at what happens to this equation here. I'll have 2z, or 2z over 1 if you want to make it into a fraction, times the 5 halves, that first term, plus, and then 2z, or if you want to make it into a fraction, 2z over 1, times the 1 over z, right, that second term, and then on the other side equals, and then 4 times 2z is simply 8z. But do you see the denominators canceling on the left side there? All right, look at the first term. I've got a factor of 2 in the numerator, a factor of 2 in the denominator. All right, so those you can divide out. Those become 1 technically, right? And then same thing for this term, this product. I've got a factor of z in the numerator and a factor of z in the denominator. So those divide out and become 1. So look at what I'm left with. All right, first term I've got z left times 5, so 5z, 5 times z, plus, and then here I've got 2 times 1, or just 2 left, equals, and then on the other side we have the 4 times 2z, that's just 8z. And again, on this new, I'm on a new page here, so I'm going to still keep this in mind. Keep in mind the fact that the value of z better not be 0 in order for all this to work. Alright, great. So as long as z is not 0, look at what happens. Right. When I multiply both sides by the LCD, something beautiful, this is beautiful compared to the original equation with all the fractions, right? People tend to like this better, because all the denominators are gone. And then I, solve it like a normal linear equation, right? This is a linear equation where the highest power on z I'm seeing any of the terms is z to the first. So I gather all the terms with z on one side, right? So I'll take this here and I'll take them to the right. It doesn't matter which side. So I'll subtract 5z and do the same thing to this side. Combine like terms, simplify. That's 0, and then plus 2 is, so I got 2 on the left, And then 8z minus 5z, those are like terms, both have z the first attached, so you just combine the coefficients. 8 minus 5 is 3, so you have 3z on the right. And then to get z alone, I want to solve for z, right? Find the value that z needs to be to satisfy this equation. I multiply by a third or divide by 3. I mean, you can just write, in a different color here. I'm dividing by 3, and I do the same thing to both sides. And if you want to switch sides, that's fine. It's okay. So I have z, put it over here on the left now, equals, and then this side is 2/3, so I'll just make that on the right side. Okay, so z equals 2/3. Notice, great, it's not 0, so that's wonderful. This is not what they call an extraneous, well, it could be an extraneous solution. We'll see more of those in the next video in part 2. There are things called extraneous solutions you might come across where you think you have a solution, but then when you go back and check it, it doesn't work. You'll see that in the next video. Now, I did mention that, though. Check your answers. Like, you're like, hey, z equals 2/3, you circle it, and you think you're finished. But a lot of times people tend to rush and don't actually, they made a little mistake somewhere and they don't realize it, and they don't bother to check their answers. So I go back to the original equation, right? Always back in the way it looked. See if this thing works. So here we go. We're going to check right here. So I've got 5 divided by 2, 5 halves, 5 over 2, plus 1 over, and then z is replaced by the number 2/3. So what we have here is what's called a complex fraction. You have a fraction in the denominator of this fraction. Fractions within fractions. And then, is that equal to 4? The question is this true? When I plug in 2/3 for z, is this a true statement? Right? Question mark. So is this side, do I have 4 equals 4, basically? All right, so let's simplify. The 5 halves doesn't simplify any further. Now, 1 divided by 2/3, you may recall from either, again, previous videos or other things you've seen, division is multiplication by the reciprocal. So when I say 1 divided by 2/3, that's the same thing as 1 times 3 halves. So this thing here is just 3 halves, 1 times 3 halves. And is that equal to 4? And now we're adding some fractions here. Look, they have the same denominator already. That's wonderful. So these two, you can actually put together. You can actually add them. They have the common denominator of 2. And that denominator stays the denominator, right? So denominator of 2, and then the numerator is just a combination of these numerators here. 5 plus 3 is 8. And maybe you can stop here. You can probably tell it's correct. Is 8 divided by 2 equal to 4? Yeah. Right, this works. But you can go one step further if you wish and say, oh look, 8 divided by 2 is 4, so the left side is 4, and the right side is 4. So yes, this is a good solution. Right. Right. And it works. It makes the original equation a true statement. And based on all our work here, that seems to be the only one. The only value. And then some people might write out, the solution set of an equation. So I'll do that down here. The solution set, where they write these little set brackets, and then inside they put all the numbers that make it true. Right? It's just 2/3, and then close it, and there you go. Here's the solution set, a collection of all the numbers that you can replace the variable with to make a true statement. I'm not going to be doing this for future examples. I'm just putting the rest of the examples on this video. I'm just going to do it this one time, but just know you might see this in some texts. But I'm just going to circle this, right? Z equals 2/3 works. Okay, great. So let me keep doing this, all right? Keep solving these equations with fractions in them. Got several more examples here for you. Alright, the next one. 2 fractions, 8 divided by x plus 4. when is that equal to 12 divided by x minus 3? All right. So first, the LCD. So the denominators here are, x plus 4, and that is its own factor. That is already factored. So I'll put it in parentheses. This is the quantity x plus 4. That is factored completely. The only other denominator is the x minus 3. Same thing. The GCF of these two terms is 1. Greatest common factor is 1. So this doesn't factor any further either. So all of it, right? The quantity x minus 3 is that totally factored. So the LCD, hopefully you're seeing this, is just x plus 4 times x minus 3, and both to the first power, because none of them show up more than once in any of the factorizations of the denominators. Alright, and don't forget, denominators can't be 0, and I'm going to be multiplying both sides by the LCD here in a second, so I want to know that it's not 0. Alright, I want to make sure that it's not 0. So I'm seeing, again, x plus 4 in denominators, so the value of x cannot be negative 4. Alright, if it were negative 4, that factor would be 0, and the whole thing would be 0, and when I multiply by the LCD later, I'd be multiplying by 0, and that would be awful. That would destroy everything. Same thing here. If I put negative 4 in here, I'd have 8 divided by 0. That's no good. X cannot be negative 4. It also, I got this factor of x minus 3 showing up in denominators. It can't be 3 either, right? Because that denominator would be 3, or this would be 3. That denominator would be 0. Sorry, 3 minus 3. This would be 3 minus 3 as well. The whole thing would be 0. And then I'd be multiplying by 0 on both sides of an equation, which is again very bad. It just destroys the entire thing, makes it 0 equals 0, and that doesn't tell me anything. That doesn't give me values that I can replace x with to make this a true statement. Right, and that's what we're trying to find. All right, so as long as these values aren't the value of x, we can continue. Alright, so as long as you keep that in mind, I'm going to multiply both sides by the LCD. Right, so here's the equation again. Right, so 8 divided by x plus 4 equals 12 over x minus 3. And I am, again, multiplying the left side by this LCD, x plus 4 times x minus 3. Sorry about the tightness there. And then multiplying the right side by the same thing, x plus 4 times x minus 3. Right. All right. And do you see how, as in the first example, when you do this, when you multiply both sides by this least common denominator, all the denominators from the problem will divide out, will cancel. You see in this first one here, I got a factor of x plus 4 in the numerator and this factor of x plus 4 in the denominator. So those go. And then on the other side of the equal sign, we've got this factor of x minus 3 in the numerator here, and this factor of x minus 3 in the denominator here. Those cancel, and becoming 1. So what am I left with? I'm left with a factor of 8 times a factor of this quantity x minus 3, the whole thing. So we're going to be distributing 8 here in a second, equals, and on this side I've got this factor of 12 left times, and then this factor of the quantity x plus 4, and again the whole thing in parentheses. I'm going to be distributing this 12. Alright, but look at the equation now though, right? It's so beautiful. It has no denominators anymore. It's not as, people consider this prettier. Alright, and then we go through and solve, right? Simplify, combine, do the distributing. We've got 8x minus 24 equals, and then 12x plus 48, and then I would take away, now me personally, I like having positive coefficients on my variables, that I'm trying to solve for. So I'll subtract 8x from both sides. This is getting kind of faint, so time for the trash. So I'll subtract 8x from both sides, combine these x terms, and that'll take all the x's to the right, and let's take all the constants to the left. So I'll get rid of this positive 48 over here, so I'll subtract 48 as well from both sides. And that'll leave me with, the 8x minus 8x is nothing, and negative 24 minus 48 would be negative 72. So I'm negative 72 on the left, and then the 48 minus 48 is 0 here, and then 12x minus 8x would be positive 4x. Alright, and then I'm again solving for just x, not 4x. So I want to multiply by 1/4, or same thing as division by 4. Right? So divide both sides by this positive 4, and again I'll switch sides here. This right side is x, so I'll make that the left side now, equals, and then negative 72 divided by positive 4 is going to be a negative number, and 4 goes into 72 18 times. Right, so this is negative 18, and that might be the answer. I am going to check it. Alright, so you go back to the original problem. Alright, let's check that right down here. So here's the original. So the left side I got 8 divided by, and then x is being replaced by negative 18. Negative 18 plus 4 in the denominator. Is that equal to 12 divided by, and then again x is being replaced by negative 18. Negative 18 minus 3 in the denominator. Alright, so this side is 8 in the numerator. Negative 18 plus 4 is negative 14 in the denominator. This side has 12 in the numerator. Then negative 18 minus 3 is negative 21 in the denominator. And both of these will be negative, right? Negative, negative. And let's see if they simplify any further, and they do. This is 2 times 4, right? This 14 is 2 times 7. 12 is 3 times 4. 21 is 3 times 7, and hopefully you can see all the common factors canceling. 2's over on this side cancel, the 3's on this side are common factors, and I am indeed seeing the same value on both sides. Negative 4/7 is indeed equal to negative 4/7. So yes, this is a true statement. Negative 18 is the solution of this equation. Alright, but please don't rush. Check your answers, and make sure that it actually makes the equation a true statement. Alright, and if it doesn't work for some reason, then that means you made an error somewhere. So that's a good reason to check. You learn from your mistakes. You go back and fix them. Okay. And again, notice that this negative 18, it wasn't one of these guys, negative 4 or 3. So that's also great. Alright, I got another one. Another few. The next one. So here we're solving for b, right? The variable in this one is b. 4 divided by 3b plus 1 over 6b equals 7 over 2b. Plus 1 over 3, 1/3. Okay. So first, the LCD. So 3b. When that factors, it's just 3 times b. This denominator, 6b. When that factors, 6 actually factors to 2 times 3. So you have 2 times 3 times b. The 2b factors to just 2 times b, and 3 just factors to 3. Right? Not a lot of factorization going on here. So then now that I have the factorizations of all my denominators, I can form the LCD. Right? The least common multiple of the denominator's least common denominator. It's going to have 2 to some power times, and then there's some 3's in here, so 3 to some power, and then there's some b's in here, so b to some power. The power on 2, let's see, 2 appears 0 times, once, 0. The largest of 0, 1, 1, and 0 is 1, so you have 2 of the first in the LCD. 3 appears once, once, 0, once, so 1, 1, 0, 1. Largest of those is 1, so 3 of the first is in the LCD. And then B appears once, 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 and no times. So 1, 1, 1, 0, the largest is 1. So it's just 2 times 3 times B, or 6B. Okay. Alright, so the LCD is 6B. And again, I want to point out that I don't want any denominators, including this LCD that I'm gonna, because I'm gonna be multiplying both sides by this. I don't want it to be 0. All right, so this LCD, denominators can't be 0, and the thing I multiply, any expression I multiply both sides of an equation by can't be 0 either. So 6 is never going to be 0, but B, that factor could be. So the value of B cannot be 0. Alright, this isn't the answer, I'm just bubbling it so I keep it in my head. Alright, and notice again, if B were 0, right, you'd have a 0 denominator there, a 0 denominator there, a 0 denominator there. That's bad, right? Always, any denominator, anytime throughout the entire course of a problem cannot be 0. Alright, so now I'm gonna, as long as B is not 0, I can do this. We can proceed. I'm gonna multiply both sides by 6B, by the LCD. Alright, so that means I'm taking this left side, again, the whole thing. There are two terms. There are two, it's the sum. There are two terms of this sum. So I'm gonna put it in parentheses, 4 over 3B plus 1 over 6B, and that's gonna get multiplied by 6B, right? Or 6B over 1 if you want to make it into a fraction. Equals, and then the other side, same thing. Got two terms and a sum, so I put in parentheses here the whole thing, 7 over 2B plus 1 over 3. And I'm going to multiply that by 6B as well, right? Multiply by the LCD. Okay, now there's going to be some distributing going on here. And I hope you can see the cancellations now. I'm going to kind of just skip to it. When I multiply the left side, oops, sorry, doing the left side first. So not the equal sign yet. Scratch that. So the left side, when I multiply this first term by 6B, when you do 6B over 3B, 3B into 6B would be 2. And you'd have a factor of 2 left over. So this ends up being 4 times 2, or 8, plus, and then times the next term, you have 6B in the denominator, then you'd have 6B in the numerator. Those would totally cancel, you'd be left with just 1. Alright, so the left side, after multiplying by 6B, is simply 8 plus 1, or 9. Alright, and then the right side, after the equal sign, multiplying this side by 6B, again, I'm just going to kind of say it out loud here. When I multiply the first term, the 7 over 2B by 6B, you'd have 2B in the denominator, 6B in the numerator, the B's would cancel, and 2 goes into 6 3 times. So you'd have a factor of 3 left over, so you really end up with 7 times 3, or 21. And then plus, and then to the next term, 1/3 times 6B. You have 3 in the denominator, 6B in the numerator. 3 goes into 6 twice, so that becomes a 2. You'd have a factor of 2 left over, and the B is still there. So 1 times 2B, you'd have 2B. Alright, so this is the equation you'd end up with, again, as long as B is not 0, and it doesn't look like it will be. And then this is a very easy equation to solve. Alright. Now that the denominators are gone, it's very pretty, very beautiful. Look at the left side, right? Now let's do some simplification. 8 plus 1 is simply 9 on the left, equals 21 plus 2B on the right. And I'll take away, I'll keep the 2B over here and I'll take away 21 from both sides. 9 minus 21 would be negative 12. Right. So I have negative 12 on the left, and then 21 minus 21 is 0, and then you still have the positive 2B on the right, and then we would divide by 2 or multiply both sides by a half. Same thing. Division by 2 is multiplying by a half. And again, I like to throw my variable on the left at the end. It's no biggie. So this side is just b. So you have b equals, and then this side is, negative 6. Negative 12 divided by positive 2 would be negative 6. All right, and I'm going to check it. All right, we're going to check this. All right, so let's check this. Go back to the original equation. Right, this is the way it originally looked. And let's plug in negative 6. Now notice that that's not 0, so it's all right. I can plug it in. The denominators won't be 0. That's great. If it were 0, if I ended up solving it and we did get 0, that'd be a problem. All right, so the first fraction, we have 4 divided by, and then 3 times negative 6. Well, I'm just going to write what that is. That's negative 18. All right, 3 times negative 6 is negative 18. So the denominator of the first fraction is negative 18 plus 1 divided by, and then this denominator is 6 times negative 6. That'd be negative 36. All right, so that's the left side. And then the right side, we have 7 divided by, and then 2 times, replacing we have negative 6. 2 times negative 6 is negative 12. And then we have plus 1/3. All right, now let's see if these are indeed the same. I'll do some simplification. 4 and 18 have a common factor of 2. Right? 2 goes into that twice, and 18 9 times. So hopefully you can see, and this would be a negative number, right? Positive divided by negative. So this would be negative 2/9, and then plus another negative, right? Positive divided by negative. So plus a negative, that's minus 1/36 equals, and then over here again another negative number, and there's no common factor with 7 and 12, so that's negative 7/12 plus 1/3. All right, and then let me simplify these. You still maybe don't see it yet. Are these indeed equal? The least common denominator, the least common denominator this side would be 36. I would just have to multiply this fraction by 4 and 4. Right, 4 in the numerator, 4 in the denominator. So I'm just going to skip to the end here. This would be negative 2 times 4, negative 8, minus 1 in the numerator, negative 9 in the numerator, and 36 in the denominator. And then 9 goes into 36 4 times. That's negative 1/4. All right, so this side is equal to negative 1/4. This side, I do the same thing where LCD is 12, right? 3 and 12. The least common multiple of 3 and 12 is 12. So I would just keep that fraction the way it is and multiply this fraction by 4/4. And we'd get something over 12, right? The common denominator. And then we'd have negative 7 plus 4. 4 times 1. Negative 7 plus 4 is negative 3. And this would be a negative number. And then 3/12, right? 3 goes into 12 4 times. So it's again negative 1/4. I am getting negative 1/4 equals negative 1/4. Hooray! Negative 6 is indeed the solution of this equation. All right? It works. It makes the equation a true statement. Fantastic. All right. So just a couple more. Doing the same. Notice I am not doing anything different. Each problem. The procedure never changes when I'm solving these equations with fractions in them. Alright, so here I have 3 halves plus 5 over x minus 3 equals x plus 9 divided by 2x minus 6. So again, I am doing, finding the LCD. Alright, so I'm finding the LCD first. So the first denominator I'm seeing is 2, which when you factor it is just 2, so there's the factorization of that. The other next denominator is x minus 3, and that's as factored as that's getting. So the quantity x minus 3, that's the only factor of x minus 3. Then 2x minus 6. Now these two terms have a GCF, a greatest common factor of 2. If I factor the 2 out, the remaining factor would be x minus 3, and there you go. They're factors of 2 and x minus 3. So the LCD is going to have a factor, 2 to some power, and I'm seeing factors of x minus 3, so times x minus 3 to some power. And each of these, the maximum number of times they show up in any of these is once, so both of those are to the first power. So this is the LCD right here. 2 times the factor of 2 times the factor of x minus 3, or if you want to distribute, that's 2x minus 6. Okay. Alright, great. So now I'm going to do this, and we want to make sure that this is not 0 ever. Right? I don't want any of my denominators to be 0, especially this LCD, because I'm going to be multiplying it by both sides by it, and I never want to multiply both sides of an equation by 0. So LCD can't be 0, implying that the value of x cannot be 3. Right? 2 is never going to be 0, this factor, but the other factor, x minus 3, that'll be 0 when x is 3. So I'm going to put this in a little bubble, so I keep it in mind, and that'll make that denominator 0. 2 times 3 minus 6, that'd be 0 as well. You can't have denominators of 0, and you can't multiply both sides of an equation by 0. That destroys everything. So as long as x is not 3, we can continue. Alright, so now I'm going to multiply both sides by the LCD. Okay, so this left side, got 3 halves plus 5 over x minus 3. Alright, and that's getting multiplied by this LCD, a factor of 2 times a factor of x minus 3. And there will be distributing involved because there are multiple terms, multiple fractions being added over there. Alright, that's the left side, equals, and then the right side is just a single fraction. You got x plus 9 in the numerator, divided by, and if you've seen any videos of mine on adding and subtracting fractions, anytime I'm working with fractions, I like to have the denominators of those fractions factored. It just makes things until the very end, it just makes things way easier for me in the long run to have those denominators factored. So this is, 2x minus 6, that factored as we saw earlier to 2 times the quantity x minus 3. Alright, and again, we're multiplying this by the LCD, 2 times the quantity x minus 3. Alright. Okay, now again, look at what happens when I distribute. Alright, so on the left side, when I multiply 2 times x minus 3 by the 3 halves, see the denominator has a 2, the numerator has a 2, those would cancel, and I'd be left with a factor of 3 and a factor of x minus 3. So the left side has 3 times the quantity x minus 3. Alright, and that's the left side. Oh, sorry. That's just the first term of the left side. My apologies. This is a plus sign. Right, let me write that in there. This is plus. My bad. And then that was the first term. Then I multiply the second fraction. We got plus, and then I take 5 over x minus 3 times the 2 times x minus 3. You see there's a factor of x minus 3. All of this is its own factor. Right? That's as factor as that gets. I have a factor of x minus 3 in the denominator, x minus 3 in the numerator, so those would cancel. And I'd be left with the 5 and the 2. And 5 times 2 is 10. Right, so this is the end of the left side. Okay. And then the right side. You see how the denominator is exactly the same as the numerator? So everything would cancel except for, and I'd be left with this factor of x plus 9. So there's only the factor of x plus 9, and since it's the only factor, there's no need for parentheses around it. Great. Alright, and then we have this equation to solve. So I'm going to simplify the sides. Right, let's distribute this, get rid of the parentheses here, and we'll combine some like terms. So we have 3x minus 9 plus 10 equals x plus 9. Then I'll combine some terms, and we'll get all the terms with my variable to the one side and all that, to all the ones without it to the other, and all that good stuff. So I've got 3x, and then the negative 9 plus 10 is plus 1. Over here I still have x plus 9. Then I'm going to take everything to one side. Let's take all the x's to the left here. So I'm going to subtract x from this side, meaning I'm going to subtract x from that side. That'll put an x term over here. And then I'm going to get rid of this 1 because it doesn't have an x on the left. Minus 1 minus 1 on both sides. And what I'm left with on the left side is 2x, right? 3x minus x, that's 2x, equals, and then over here, the x's are gone, and then 9 plus negative 1, 9 minus 1 is 8. And then finally, division by 2, right? Or you can multiply by a half or divide by 2, means the same thing. Divide both sides by 2, and 8 divided by 2 is 4. So I got 1x, the value of x is 4. And let's check it. Check the value of 4 back in the original equation. Alright, so the left side, I've got 3 halves plus, and then 5 in the numerator over, when x is replaced with 4. 4 minus 3 is 1. So really that's just 5. Alright, but I'm going to put these together in a second, so I'm going to change this so that they both have the same denominator, and then I can add them. Then on the other side, x is 4, so 4 plus 9 in the numerator, that's 13. And then 2 times 4 is 8, and then 8 minus 6 is 2, so you have 2 in the denominator. Alright, then on the left side, the LCD would be 2. I'd multiply this fraction by 2 in the numerator, 2 in the denominator, to get the denominator of 2. And we have 3 plus, 5 times 2. Well, 3 plus, 10, that's 13 in the numerator, and then they have the common denominator of 2. So I've got 13, I get 13 halves equals 13 halves. Yes, this is indeed the solution of the equation. The value 4 will replace x and make a true statement. Alright, great. And again, always check your solutions. Right? You might have made a tiny error, especially if you've rushed it. Right? Try not to rush things. Alright, and I've got one last example. I'm doing pretty much the same thing. Just one last time here. Solve this equation with the variable x. So first the LCD. Alright, so my one denominator, x minus 3, that's as factored as it gets, so that's it. The quantity x minus 3, that is the only factor of that denominator. The other denominator I'm seeing is x plus 3. And the only factor of that denominator is x plus 3, so I got the quantity x plus 3. And the denominator on the 1 is 1, right? So that's not interesting. That doesn't add any information, help me out at all. Alright, so now that I've got the factorizations of the denominators, the LCD is going to have, some power, x minus 3 to some power, and times x plus 3 to some power. And none of these factors appear more than once in any of the factorizations, so it's all to the first power. Alright, so x minus 3 times x plus 3 is the LCD. So this is what I'm going to multiply both sides by. And I want to make sure that, since I'm multiplying both sides by it, I don't want it to be 0. Alright, so the LCD, this down, it can't be 0, implying that, the value of x shouldn't be 3 or negative 3. Alright, because if x were 3, this factor would be 0, making this all 0. This would be 0, making that denominator 0, so that's no good. And negative 3, same thing. This would make this factor 0, which would make the whole thing 0. I would multiply both sides by 0, that's bad. Or replace x with negative 3 in this fraction, you'd be dividing by 0, that's also bad. Undefined. And I'll put that little bubble. Keep that in mind, just so I know that, if I get solutions at the end, hopefully they're not 3 or negative 3, because if they are, I'm in trouble. Right? That means I have no solution, or what are called extraneous solutions to the problem. Okay, so now comes the multiplication part. I'm going to take this left side, and it's got 2 fractions being subtracted. It's got 2 terms, so I'll put it in parentheses. 4 divided by x minus 3 minus 3 divided by x plus 3. And that's getting multiplied by the LCD, both of these factors, x minus 3 times x plus 3. Alright, and again, there's going to be some distributing going on here. Alright, equals, and then the other side is just 1 times the LCD, so x minus 3 times x plus 3. Alright, so Great, let's do this. Now, distribute. So on the left side, see when I multiply this first fraction by the LCD, say I have x minus 3, that factor in the denominator, x minus 3 in the numerator. So this would cancel that, and I'd be left with a factor of 4 and a factor of x plus 3. So 4 times the quantity, the factor x plus 3. Then I have minus, and then again distributing this LCD to the second term, the second fraction. Say I have a denominator with a factor of x plus 3. The numerator would have a factor of x plus 3, so this x plus 3 would cancel with that x plus 3, and I'd be left with 3, a factor of 3, and a factor of x minus 3. So 3 times the quantity x minus 3. Alright, so that's the left side. And then the right side is simply the LCD, right? Anything times 1 is itself, so it's x minus 3 times x plus 3. Great. And now this is going to be a little different than my previous examples because you're going to see that I'm going to end up having to solve a quadratic equation here, where the highest power on x is to the second power. So let's get rid of these parentheses, right? Let's simplify this a bit. So distributing the 4 here to the factor x plus 3 gives me 4x plus 12. And then here, now remember, technically this is, when you subtract, you're adding a negative. So this is really like plus negative 3 times x minus 3, So you're distributing not just the 3, but negative 3 to that next factor. Alright, so negative 3 times x, negative 3x, and then negative 3 times negative 3 would be positive 9. Alright, so be careful with that. When you're distributing over a factor, over some sum or difference, when you're distributing, if there's a minus sign, that negative is part of the number you're distributing. Right, that's part of the term. Okay, and then the other side, we're going to FOIL, right, do all sorts of distributing here. X minus 3 times x plus 3, you'd have x squared plus 3x, then minus 3x minus 9, right, after distributing the x and then distributing the negative 3 to this x plus 3. So I have x squared, and then plus 3x minus 3x, so that'd be 0, and then minus 9. Alright, so you see how it's a quadratic equation, right? There's x to the second power. And I've put up some videos on quadratic equations, or solving quadratic equations by factoring. So for most equations that are higher than degree 1 or higher than a linear equation, like this, right? This is degree 2. A good first step would be to put it in what's called standard form, where I take everything to one side and 0 on the other, right? So I'm going to do that here after some simplification, right? Let's combine some like terms here. This left side, 4x minus 3x, is just 1x, and then the positive 12 and the positive 9 make plus 21 equals, and then over here you have x squared minus 9. And I'm going to take everything to, just because I like having my coefficient on the highest powered term, my lead coefficient, I like it to be positive. I'm going to leave x squared on the right here and take everything to the right. So I'm going to take away x from both sides and take away 21 from both sides, and we'll combine like terms. So I've got 0 here on the left now, nothing, right? 0 left. And then on the right side, I have a 1x squared, right? There's no other x squared term. I have a minus x, right? There's no other x term. And then the two constants, I have negative 9 minus 21. Put those together, that makes negative 30. Alright, so this is what they would call the standard form for a quadratic equation. You have all the polynomial on one side, 0 on the other. And then we factor. If you can, you could use what's called the quadratic formula if you want, or solve it by completing the square. You can look up other videos on that, but this one is able to be solved by factoring. So I have 0 on the left, and then the way this x squared minus x minus 30 would factor would be you'd have a factor of x minus 6 and then multiplied by a factor of x plus 5. And you can go ahead and check that, distribute the x to the x plus 5, distribute the negative 6 to the x plus 5, and then combine like terms. You'll get x squared minus x minus 30 back, I promise you. Alright, and then from here, we apply what's called the zero product property. Alright, which states that if you have a product equal to 0, then you know that one of those factors must be 0, right? Because anything times 0 is 0. So if x minus 6 times x plus 5 is 0, then that means either x minus 6 equals 0 or x plus 5 is the 0. And solving each of these gives me my possible solutions. Now we have a couple. We took a quadratic equation, a degree 2 equation, and broke it up into two linear equations or degree 1 equations, and these are easy to solve. Then I would add 6. X equals 6 as a possible solution, or and then subtracting 5 from both sides of this, x equals negative 5 as a possible solution. Alright, so this time, because there was a quadratic, I end up with 2, and that'll sometimes happen, degree 2, you end up with 2 solutions. But that doesn't mean they're both going to work though. Alright, you must check both of them. And that's exactly what I'm going to do on this next page. Alright, so let us check. Alright, so first I'll check x equals 6. Alright, so we're going to go back to the original equation. Alright, this is all the way back here. Here's how it looked. Now notice that 6 and I got 6 or negative 5. 6 or negative 5. Those are not one of these guys that we said earlier that x couldn't be. So we're okay. I mean, if I did everything correctly, the 6 and the negative 5 should work. Let's see. So the first one, I got 4 over, and then 6 minus 3 is 3, so I got 4/3 minus, and then 3 over, and then 6 plus 3 is 9, and is that equal to 1? Well, 3/9 reduces to 1/3, right? 3 goes into 9 3 times, so that's 4/3 minus 1/3 equals 1, and now I'm subtracting a couple fractions and they have the same denominator, so I can actually subtract these and they'll have a denominator of 3, and 4 minus 1 will be the numerator. 4 minus 1 is 3. 4/3 minus 1/3 is 3/3, and yes, 3 divided by 3 is in fact 1. You get 1 equals 1. So yes, x equals 6. 6 is a valid solution of this equation. Alright, now on this other side here, let's check the other one. X equals negative 5. I believe it was negative 5. Yes, negative 5. So again, back to the original equation. So the first fraction, you have 4 divided by, and then negative 5 minus 3 would be negative 8. 4 divided by negative 8, so negative 4/8. Right, positive divided by negative would be negative. So negative 4/8, and then minus, and then 3 over, now negative 5 plus 3 would be negative 2. So 3 divided by negative 2, so that'd be minus negative 3/2 or plus 3/2. Alright, and is this equal to 1? Now 4/8 reduces to 1/2, so that's negative 1/2 plus 3/2 equals 1. And these have a common denominator now, so I can actually add these, and that denominator will stick around. So 2 in the denominator. And the numerator is going to be negative 1 plus 3. Negative 1 plus 3 is 2. And indeed, yes, 2 divided by 2 is 1. You get 1 equals 1. They both work. So here's an example where the equation with fractions here had 2 solutions. So 6 works in here, makes it a true statement. Negative 5 also works, makes it a true statement. Wonderful. Alright, so for solving these, right, first, find the LCD. Second, stay off to the side, just keep it in your head. What values would make the LCD 0? Because you're going to then multiply both sides by the LCD to cancel all the fractions away, cancel all the denominators, and then solve the resulting equation, whether it be linear or quadratic or whatever. And of course, once you've solved, check your solutions back in the original equation, please. So just make certain that you didn't make any mistakes, small mistakes along the way. All right. And as usual, at the end of these, I like to say, please try to understand the material as best you can on your own before looking for help. Read through the material that you're given, read through author's examples, maybe even try to work out the examples before you read how the author does it, just to see how it goes. Practice exercises, look up solutions to those exercises to see how you did. And don't just give up after the first try, right? Keep going. If after several attempts at a problem you're still not getting it, it's still not clicking, try reading through the section again, reading through the material again, maybe even a third time, because perhaps a second or third read through, something will click that didn't click for you before. Something will make sense. You'll have like one of those aha moments. But if after several read-throughs of the material, several attempts at the exercises, and it's still not working for you, then please, it is not a sign of weakness whatsoever to go looking for help. Go ask for help. That is what other people are there for. Ask a teacher, a tutor, somebody who's in a friend of yours in the class, someone who knows the material. Look for online materials, some extra online supplemental materials. Look for videos online on the material like this one or other ones out there that are better than the ones I have provided you, I am sure. I guarantee you they're out there. And just keep at it. Stay persistent. Keep practicing. Never give up. And I know you'll get it. I know you'll eventually get it. And try to have fun with it. It's no good when you go in and think you're going to hate it right away. Because if you think that ahead of time, that you're going to hate it, you're going to hate it. I hate math. I hate math. I hate math. That's going to happen. You're going to hate it. Try to change your mindset. Try to go in with an open mind. Think, I could learn something here. I could have fun with this. I could enjoy this. And perhaps you will. And that might make all the difference. So keep at it. Stay persistent. Keep practicing and have fun. And thank you for watching.